to research for information of non-Newtonian fluids.
Where we can look it for?
Maybe YouTube. Let's look into some videos and research for some information.
Yeah.
Oh, look this one. This looks interesting.
Before we can see the difference between the Newtonian fluid and the non-Newtonian fluid, we need to understand the definition of the equation. The equation is the action or the property of the molecules for sticking together and being mutually attractive. So it's one another and then combine, and it's the equation first.
So now we're going to explain the difference between a Newtonian fluid and a non-Newtonian fluid and why there is this difference. So now here we have the difference between a Newtonian fluid and a non-Newtonian fluid based in 2 points of view. The first one is the relation between the velocity and the cutting rate to produce the necessary amount of work on a Newtonian fluid. Just in case you didn't know, the cutting rate measures the gradient of velocity at which movement is generated between the layers of the fluid. Or, the second point of view, it's the value of viscosity that remains constant despite the type of work or force that may be applied to the fluid. And now we have the non-Newtonian fluid. There are 3 types of non-Newtonian fluids: the pseudoplastics, plastics, and dilutant ones. The way to understand how a non-Newtonian fluid works, there are 2 points of view also. The first one is that there is no relation at all between the viscosity of the fluid and the type of work or force that it is applied. On the other hand, if the force applied to the fluid is a big, very fast, and unexpected one, the fluid will behave like a solid. So now we know that there is a difference between the Newtonian fluid and the non-Newtonian fluid. But why there is this difference? Easy. Because the non-Newtonian fluid does not have a constant viscosity and they don't have an established value of temperature and pressure at the beginning, such as the Newtonian fluids. That's why they don't follow a linear relation between tangential tensions and deformation speed.
Wow! Here we can see that on the y-axis the viscosity is expressed, while on the x-axis is ubicated the cutoff rate in relation to a certain speed, and that is the graphic behavior of each fluid.
Some real-life examples for the non-Newtonian fluids are the honey, the toothpaste, the blood, some starch solutions, and the custard. And it's a dessert based on cream and milk, and it's cooked with egg yolk.
During the experimentation, we will use 2 cups of starch, 1 cup of water, coloring, a container, and a spoon. Here it can be observed that when applying a slight force, the fluid behaves like a liquid. However, when applying more force, it behaves more solidly. Well, the creation of a non-Newtonian fluid is easier than I thought.
Yes, it's an interesting subject.